So these illustrations at the top are examples of how the graphs interact. So you guys could have these two quadratic functions intersect twice, once, or not at all. So just like last time, for these systems, you could have two solutions, one solution, or no solutions. So when you guys, and I'll recap this again at the end, when you guys continue working on that slide project that we started last time, your next couple of problems, problem number 1 was the example I gave you, and then 2, 3, and 4 were the linear quadratic that you guys started last time. Problems 5, 6, and 7 are going to be the quadratic systems for 1, 2, and no solution. So at the end of this lesson, this round of slides, you guys should have 7 problems total. We're going to start with the graphing method, just like we did last time. So it's the same deal. You have to make sure that both the curve equations are set up with this y equals for those. You can't graph unless they're written appropriately. So you might need to rearrange stuff, maybe add, maybe divide, whatever it is. You need to make sure everything fits in the form y equals everything else. Then you guys are going to graph both of these. They're both going to be parabolas. You don't have a line anymore. You're going to have two curves. And you'll notice that sometimes they'll give it to you in standard form where you guys don't have parentheses, and then sometimes they'll pull out the vertex form that we learned as well, where it does have parentheses. So you guys need to remember both of those different strategies for graphing. Then once you guys have your graph there, look for the points of intersection, and you would write those down. Just remember, the solution to a system is the point where the graphs intersect. You guys can also use your graphing calculator, like I had that little description somewhere in the notes on day 1, how you can use your TI device, or you guys can use Desmos to check your answers too. But again, those should not be your primary way of solving. I need to actually physically see the graphs that you guys have done by hand. So if we're starting with this one right here, both of my equations are written as y equals already, so I don't have any extra work to do there. This top one is in standard form, right? It doesn't have any parentheses, so I'm going to start with that. You guys can start wherever you want, but I'm going to start there. So in standard form, how do you guys graph? How? Negative b over 2a. So you can see that there are no parentheses. We're going to be using the negative b over 2a method. So what would b be? 0, because it's not there, right? b is supposed to be in front of the x term, and there is no x term. So b is 0. So it's 0 divided by 2 times negative 1. What's 0 divided by anything, regardless of what the denominator is? So 0. So for this one's vertex, the x value is 0. How do I find the y? Plug it in. So if I plug in 0, what is negative 0 squared? 0. So my first graph is the vertex is at the origin. The vertex for this one. Then how do you get the rest of the curve? Remember, it's curved, so it's not sloped. Okay, so you multiply 1, 3, and 5 times whatever the value of a was. So look back at your equation, what was a? So you're going to multiply 1, 3, and 5 times negative 1. You get negative 1, negative 3, negative 5. Alright, so for this one, I have negative 1, negative 3, and negative 5. Okay, so that means I'm going to go down 1 over 1, and then down 3 and over 1, and then down 5. 1, 2, 3, 4, 5, and 1. Like that. Let's see, then how do I get the rest of it? Same thing to the left, right? Down 1 over 1, descend to the left, and then down 3 and over 1. And then down 5, 1, 2, 5, 1. So this is my first graph. That's the first one. Now the second graph is in vertex form. I still need to know the vertexes, and I still need to know the 1a, 3a, 5a stuff. But how you do that slightly differently when you have parentheses in vertex form. You use these two. There's no negative b over 2a because this doesn't have a b or a c or anything. It does have the a in common, but it doesn't have a b. We use h and k. That's what they call these two numbers. So it's the inside number and the outside number. Did you guys remember we had to do special?
Change inside negative.
Right. Change the number that was on the inside of the parentheses to the opposite sign. So when you're finding the vertex for this one, it would just be opposite this number and then that number. So negative 2, negative 4. You can already see that they have one spot where they're going to be crossing each other. Right? And how do I get the rest of the curve?
3, 5.
1, 3, and 5 multiplied times a. And this equation, what's a? Right, the number in front of the parentheses, which would be a 1, invisible 1. So 135 times 1 just means they say 135. So I'm going to go up 1 over 1, up 3 over 1, and up 5 over 1. And then you do the same thing on the left. Just make sure you're graphing the parabolas all the way. I can understand that you guys now see the points of intersection before you even graph it. But part of the question is being able to synthesize that curve. Make sure that you are graphing both of them completely. Then after that, you can write down the points of intersection. All right, how many times do these two graphs cross each other? Twice. So you need to look for those points where they're crossing and write them down. What would one of them be? 0, 0. Negative 2, negative 4. Okay? That's the first one. Now let's do the second one. Example 2. Are they both set up and ready to be graphed? What's wrong? This first one, is that written as y equals? No. This one I'm going to have to neaten it up a little bit. I'm going to add the 4 to the other side. So it looks like that instead of this. And then they're both set up and graphed. Alright, both of these are set up in standard form, so we're going to be using the negative b over 2a for both of them. So how would I find the vertex for this? What's b? B is 0. Remember, b is supposed to be in front of the x term, and this doesn't have an x, right? So if you don't see the x, then b would be 0. That's what makes the x disappear. This one would be 0 over 2, right? But that's a 0. 0 divided by anything is 0. So for this first graph, the x value is 0. How do I find the y value? Plug it in. So you plug in 0. 0 squared plus 4 is 4. So my first graph has a vertex at 0, 4. One, 2, 3. There we go. Alright, how do I get the rest of the curve? 1a, 3a, 5a. What's a for the first function? 1. So it just stays 1, 3, 5. Okay? So it means they go up 1 over 1, up 3 over 1, and then the 5 goes off the graph, so you don't have to do that one. So we're just going to do the 1 and the 3, so that's what fits. Yeah. Okay, everybody clear with the first one? Alright, what about the second one? Again, negative b over 2a. This one doesn't have parentheses, so we're going to do the negative b over 2a again. What's b? 0 again, because it doesn't have a x term, so that means it doesn't have the b, that would be a 0. And so again, 0 divided by anything is 0. So the x value is 0. How do I find the y? Plug it in. I plug it in, I get negative 0 squared, which is still 0. And then plus 4.
0, 4.
Yes. So interestingly, they both have the same vertex. If they have the same vertex, does that mean they have to be the exact same graph?
No.
No. So what would be different about how I graph this one? It's facing down, right? Because then the a value in front is negative. So when you guys do the 1a, 3a, 5a, you're going to be multiplying times negative 1. So now it's going to be negative 1, negative 3, negative 5. So down 1 over 1, 3 over 1, and then down 1, 2, 3, 4, 5 over 1. Then you repeat that on the left. Okay. Once you're getting a little bit smudgy, graph the curve. Okay. So how many solutions does this one have? Only one. And what is that solution? So again, this should not be new. We've been graphing parabolas. This is the first half of Unit 2. So again, that's where you would go to find more information if you're still shaking on it, but this is prerequisite knowledge. You guys should know how to do this. So the whole graphing strategy shouldn't be that bad. You just have to remember the difference between when you use the negative b over 2a and when you use the h to h in regard to parentheses when you're using vertex form. So make sure you guys are able to differentiate that. Any questions? Alright, now we're going to revisit substitution. So it's going to be exactly like we saw last time. The substitution. This can be used in any situation except for when you guys have a coefficient in front of the y. If you try to divide it away, you get fractions, but that was really not possible for us to factor. So for this one, again, you're going to rearrange both equations so that they're in the form y equals everything else. You want to get everything away from the y, including any coefficients if you can. Then you're going to set both of the expressions equal to each other. Remember how we were talking about the transitive property? If a equals b and b equals c, then a equals c. That's what we're going to be doing. We're going to take both of the expressions on the right-hand side and set them equal to each other. Then you rearrange and factor solve, just like we did last time. Okay? So for example number 1, is that set up and ready to go immediately into substitution? What's wrong? Alright, so I noticed the very first equation, for example 1, there is a coefficient in front of the y, and you should be careful with that. Here's a better question, can I divide the coefficient away and everything still be whole numbers? Yes. If this is like a 3, would I be able to do that? No. Then you would have to use elimination. But for this one, you can just divide everything by 2. The first equation becomes that. I don't have this anymore, I have that. I divide everything by 2. Now it's just y by itself. That's what we want it to be for substitution. So once you fix the first equation, you get this. They're both equal to y, so they're equal to each other. Right? So the next step would be to take this right here and set it equal to this. So negative x squared plus 4x minus 1 is equal to x squared minus 2x minus 1. Both of the expressions on the right-hand side of each equation, set them equal to each other. What's cool about that is that we no longer have y. Okay, so we can solve now because we only have one variable in our entire equation we can solve. But what do I have to do before I can use factoring? I need everything on one side. So you have to start with them being kind of juxtaposed so that you have something on one side, something on the other, and then you have to move them over to another side. Don't try to do both of those at the same time. You get stupid. So here, I'm going to go ahead and move everything over to the right-hand side, okay? Because I noticed that there's a negative in front of the x squared. If you guys have a negative in front of the x squared, you probably have to pull out a GCF, and the negative one can be a little bit tricky to remember the sign. So I personally am going to choose to go this way. You can choose to go the other way. You just have to be super careful about the GCF. So if I pull everything over to the other side, it means I'm adding an x squared, so that would be 2x squared, subtracting the 4x, so that would be negative 6x, adding the 1, so it goes away. So that's my expression. Yes. Okay, so again, you can have it right or left, doesn't really matter, but you should get something that sort of looks like this, depending which direction you go. Alright, so would I use that x method thing to factor this?
Not yet.
I mean, not yet. Okay, so always look for a GCF first. So does this have a GCF?
Yeah.
What is it? 2x. So I would rewrite it as 2x, and then what would be left behind in the parentheses?
X minus 3.
Okay. Can I keep factoring the x minus 3?
No.
No, once it's linear and there are no more powers or anything that can be factored using the methods we learned, you're done. So how would I solve this then? You set both factors equal to 0, given that your factors have an x in them. If the GCF is just a random 2, you wouldn't use that to solve because it doesn't have an x. But if your GCF does have an x, you would set it equal to 0. Okay. So I have 2x equals 0 and x minus 3 equals 0. What are my two x values that I would get? This one would give me 0, and this one would give me 3. Everybody see that? The number of factors that you have with x's in them, that's how many x's you should have. So if your GCF involves an x, that's going to be one of the equations that you would get. It doesn't have an x, and then creating 2 equals 0 doesn't make any sense. It's not going to get you anywhere. It must have an x in it. Alright, so I have two x's, it means I have two solutions, that means I need to have two y's. How do I find the y's? Yep. Take your zero and your 3 and plug them in. It doesn't matter which equation you plug them into, just make sure that you're being really careful. I personally am going to go ahead and plug them into this one that we got from dividing everything by 2. Dividing 0 squared minus 2 times 0, all this is 0 minus 1, that gives me a negative 1. And then when I plug in 3, that's 9 minus 6, 3 minus 1 is 2. Okay? Hmm?
Then we got negative. Oh, wait.
Then your point, make sure you're writing in a point that would have 0, negative 1, both of these put together, and then I would have 3 and 2, because this is the x and that's the y. So just drop it up, make sure you write them as ordered pairs, and then that would be yours. Questions on that one?
Yeah.
Just plug in 0. 0 squared is 0, negative 2 times 0 is 0, 0 minus 0 is 0, 0 minus 1 is negative 1. You're going to do it, it really shouldn't be that hard to do in your head.
Fair question.
Sure.
When you do, when you have the 2x, x minus 3, so like, I kind of did that on the quiz, but I added 0, so like, so I did 2x.
Equals 0.
Oh, that's whatever.
Any other questions on the first two examples? Alright, we're going to do the second one together, and then you guys will do this. Oh, so for this one, is it set up and ready to go for factoring? Or, sorry, the substitution method. What's wrong with it?
Why?
Specifically, what is wrong with the way that it's written?
The y isn't on the
Which one? Okay, so the top one is fine. It's already set up with the y equals everything else in standard form, but the bottom one is not. So what I'm going to do is I'm going to go ahead and put the y on this side. I'm going to basically switch the y into 15. So I'm going to write it as negative 2x squared plus 12x minus 15 equals y. So add the y and subtract 15. So whether the y is on the left-hand side of the equation or the right-hand side of the equation does not matter. You just need to make sure that the y is by itself, and then everything else on the other side, you're going to set it equal to this expression right here. Alright, does everybody see where I am so far? Alright, so I'm going to take this expression and this expression, what the y's are equal to, and put them equal to each other. That's the substitution part.
So if I were doing it the other way, like I put y equals on the left side, wouldn't I get positive 2x squared?
Nope, because then you'd have to divide by the negative that's in front of the y. There's negative right here. You move everything over here, you still have to divide by the minus. That's why it's easier to just move the y over. Alright, everybody agree with where we are? Alright, what do I do next? Make one side 0, that means everything else has to go to the other side. So I'm going to add everything over to this side this time to get the x positive. So I'm going to add the 2x, that makes this 3x squared. I'm going to subtract the 12, that makes this negative 18x. I'm going to add the 15, that makes this 27. Does everybody still agree? Are you tracking? Alright, now what would I do?
How'd you?
What do I do now?
Because you did negative 15 plus,
Add the 15 to the 12 equals 27.
minus.
So there is a GCF 3. You remove the GCF by dividing it away.
If you do negative. Oh, 12 plus.
Yes. 27. Alright, once you pull the GCS of the 3 out, what would I do next? What strategy do I use to factor something like that? A little X trick, right? So multiply the first. The 3 is now kind of outside of the whole situation that we're factoring. We're focusing on what's inside the parentheses. Now the number in the front is a 1 and 9. You multiply those together, you get 9. And then the middle number is negative 6. Yes, negative 3 and negative 3.
If I set up the negative 3 squared on the other side, like flip it around.
Like those?
Yeah. Is it okay that I'm getting like, will I still get the same answer?
Yeah, it just means if you pull everything to the other, like if you have this reversed and you bring everything to the left, that'll be negative. You have to include the negatives. Yeah. You're going to confuse yourself if you're not doing what I'm doing. Alright, so with the 3 as the GCF, actually I'm going to leave this 3 alone until the very end. I'm going to write it down here just to remember it's there. So remember when you guys are doing this factoring, you remove the negative 6x and replace it with these two numbers, right? The x's. Split down the middle. What do I do from here? Okay, so what do these two things have in common? Both x. I have x, and I have x minus 3 left over when I divide x away, undistribute. What's the GCF on this side? 3. Okay. So then what would my two factors be?
X minus 3, x plus 3.
What?
Yeah, x minus 3.
No plus. Minus what then?
No,
When you're factoring, you have to write it twice. When you are solving, you guys are going to get 3 both times. I don't want you to write x equals 3 twice. Okay? This is the factored form. You don't want to mess with how you're changing the factored form. It's after you factored how you then deal with that. If you have 2 of the same factors, then you just have 1 solution, and you guys are solving. So what is the x value you get when you solve? 3. And that has no relation to the fact that you get 3. Right? This GCF has no x on it, so it's not involved in the solving process. So x is equal to 3. How do I find the y? Plug it back into one of your equations up top. I'm going to plug it into this first one here because it was already printed correctly for us here. Just in case I made a mistake, I don't want to plug into that one. So I do 9 minus 18 is negative 9, 12. 3. And that's pretty obvious. You can't see this equals 0 and try to solve that. My solution, the x was a 3, and from that I got y was 3, so my solution is 3.
So like, what would you?
From here, you can divide it by 3.
Yeah, but you have 3 parentheses x.
Does this have an x with it? Then it's not involved in solving whatsoever. You only solve for what has an x in it. Different from this one, this GCF did have an x. Yes, it does not. So it is not involved in the solving process. You only take what has an x with it and put it with your 3 is completely irrelevant. The 3 needs to be there for the factored form. It is irrelevant. Okay, so everybody understand how we got 3, 3? Alright, try this last one by yourself. Give you a few minutes, I'll put the answers on the board so you guys can check to see if you did it correctly. Move on to the next process. Alright, you guys do that. You should get that. You should get that. Give you a second to reevaluate your work. If not get that, and then we'll move on to the next page. There are no questions. looking at the elimination method again. We did this last class. It's only going to look slightly different because now we have two quadratics instead of one quadratic line. Again, the process and everything is going to be exactly the same. So again, this is what you guys want to use with your coefficients in front of the y. You can't divide those away without getting fractions, which wouldn't work for the substitution. So you guys are going to rearrange both equations again, so that's y equals everything else, but remember that coefficients are okay here. You don't have to get rid of the coefficient in front of y if you have one, unless they can't be divided away evenly, in which case you keep substituting. But this is when that doesn't happen. You're going to multiply one or both of the equations by some number that will make the values for the coefficients of the y's opposite. So for example, if one coefficient was 2, you would want the other coefficient to be -2. If one was -5, you would want the other one to be +5. You want them to be the same number but opposite signs. So when you add them together, you're going to add, I think you got your guys' subtract again. You have to add when your coefficients are opposites, you're going to add the equations together and then once you cancel out the y values, leaving you with only x's, and then you would factor and solve just like you do in substitution. So it's really just the beginning part that's different, how you manipulate the equations to get just x's instead of y's. And then again, once you find the x's, you plug back in to find the y's, and you write your answers. This should not be good. Yeah, right. So I changed this already, but you guys should, instead of subtracting, you should change it to say add. Alright, so let's take a look at example number 1. So first of all, you need both equations to be written with the y term equals everything else. So this one has, it says the y term equals everything else. If I try to divide by 2, would that work out nicely for us? No. So this one we're going to leave it alone. This is going to indicate that we need to use the elimination method, that we don't get rid of the 2. What about for this one? Move the 5x squared over, because the y term needs to by itself. So I write 7y equals -5x squared plus 3. Make sure it's in standard form, so shift 3 over and put the -5x squared in front. Now it's set up. If I try to divide by 7, would that work nicely for us? So now both of our equations are set up the way that they need to be. This one has a coefficient of 2. This one has a coefficient of 7. How do I get those numbers to be opposites? So what coefficients are you last with? What's the final product? What coefficients? 14 and -14. It's kind of like thinking about the least common multiple, kind of, if you guys remember that. 2 and 7, obviously, they're not the same number. You need to multiply both equations so they get to the same number, and the lowest number that they can both multiply up to is 14. So I'm going to need to multiply the top equation. How do I get 2 to become 14? Multiply times 7. I'm going to take the top equation and multiply times 7. So that would give me 14y -21x squared. Yes. Forget this one. Oops. 26 times 7. Everybody with me on the first one? Alright, now the bottom equation starts off at 7y, but because this one's 14, I need that to be a -14. I'm going to multiply the second equation by -2. That means -14y positive 10x squared negative. Right? Sometimes you do have to multiply both equations, not just one, where you have to use coefficients. Right, now these are opposite of what we were after, so when you add down, we're going to add down the columns, those y's disappear. You have -21x squared plus 10x squared, and then we have 182 plus -6, which is the same thing as subtracting 6. Or how would I solve this? Okay, hold on. Think about it for a second. Would factoring be the appropriate method to solve this? Okay. Yeah. Okay. -11. So what does that leave you with?
X squared minus.
Okay. It's not called the square root. You can use square root from the get-go, but if you're going to factor, it's not called square root. You certainly can't factor x squared minus 16. The square root step, remember that? You guys have the GCF up front, but then how do you factor this so they're both starting somewhere?
So.
So it just turned into x minus 4. That. How many factors did you have when you factored? Then you should just have one, but it's still. Then x minus 4, x plus 4. You guys factor. You don't actually write it with plus or minus. It's separate them. Right. So the GCF being -11 without an x, you do not use the -11 to help you solve. It's not a variable, it's not going to solve, it's not an equation. You're just going to set these equal to 0. What do I get from the first factor? Positive 4. Second one? Alright, so we have two solutions. The first solution has an x value of 4, and the other one has an x value of -4. How do I find the y? Plug it in, doesn't matter which one I plug into. Yeah. So I'm going to go ahead and plug into the top one. Here. So I'm going to plug in the 4, so that's 4 squared is 16, -3 times 16, and then plus 26, and then all of that divided by 2. -11. Make sure you're careful because this one had a coefficient, you have to divide that by yourself. And then I'm going to try -4 this time. I believe it should be the same answer because when you do -4 squared, it becomes positive 16 again. And then add the -3 plus the minus divided by 2. You're going to get -11. So, my solutions are 4 -11 and -4. They look really similar. Okay. Yeah, we're right next to them. Alright. Any questions about the first one? Okay. What about the second one? It's already set up, however, it's set up so the y's are by themselves, everything else is off to the other side. But how would I need to affect or change this so I can use the elimination method? Right. Multiply 1 by negative. Right now the coefficients are the same, and for the addition process they tend to be opposite. So you can pick your favorite. I think I'm going to go after the second one here. I'm going to change all the signs. Plus minus plus. So you're just going to multiply one of the equations by -1 so that everything is the opposite sign, and then you can add. Okay. This one you could actually use either elimination or substitution, right? But because we're in the elimination method, I'm just going to show you how you would do it that way. So if I have positive y plus negative y, what happens? You cancel. That's the whole point of this method. So I have x squared plus x squared, which is 2x squared, negative 17x, plus another negative 17x, and then 78 plus 62. 40. The square root. If you had done the substitution method, you would have gotten to this exact same spot after doing the substitution. Now what do I do? Yeah, I did. I get x squared minus 17x plus what? divided by 2. And then 1 is at 17. Alright. Now again, the GCF is part of the factor part, the final representation of factoring, but it's not called this following. So I'm going to use my little x. I use numbers that multiply to get 17, but add to get negative 17. Negative 7. And I have x squared minus negative 7x plus 17. And down the middle. Hopefully you guys are doing this faster and faster the more we do factoring. You should really be thinking it better. What's the easy on one side? X, I have x minus 10 left. What's the easy over here? Leaving me what behind? Okay, that's a good sign, right? Shows us that we picked the correct GCF. Now what's my final solution here? Or factor. Okay, how many solutions am I going to have? 2. 1 from here, 1 from here. So my first x would be, the next one would be 10. So I have 7 and 10. Now we need to go on to find the y values. Big numbers. So 49 minus 17 times 7, 158 is 8. 7 is 10, so 100 minus 170 plus 78. Which is also 8. Enough? That's cool. Alright, my final solution will be 7, 8. Alright, now you guys can go ahead and do example number 3 on your own. See if you can figure that one out. As you guys are wrapping up or close to wrapping up. Sure, this one just has one solution. Next one. Or next one. It shouldn't make any difference. It would just make all the incident all the time. It's either that or the opposite sign. So when you guys are factoring, it should be either positive 36 or negative 36, depending on which equation you put the negative with, and then 12 or negative 12, again, depending on which one you put the negative with. So that's where you get only one solution, because when you factor, the numbers should be negative 6. Yeah, technically this one you could use substitution, but we're in the elimination section, so I want you to practice using substitution.
Wait, can you do this? Yeah,
Your original
it changed just to negative Yeah, I got it.
Positive. That's negative. And then factor. Again, you still get negative 6. Multiply to get positive 36x, and I get 12 to get 6, negative 6. 6. I'll get the x would be 6 by itself, and plug it in, you get 1. Getting this question wrong should be a matter of getting the 536. Alright, so that was an example. Again, you guys can either have 2 solutions, 1 solution, or no solution. The only time where you guys would really run into a scenario where you have no solution would be graphically. If you graph it and you see that they don't intersect, that's no solution. Or if you guys are doing this algebraically, which I can almost guarantee you guys will not run into. If you're doing it algebraically, you get something that you can't factor. If you can't factor it, that would be a no solution scenario. But again, I guarantee you guys will not run into it. The last concept that we're going to talk about is what if I kind of go backwards? What if I present a solution to you and I want to know if that point would actually be a solution for the system that I'm also presenting to you. So I'll give you a system and a point and I want to know if they can merge together and the point would be a solution. Now this one is pretty simple. So you're going to plug in x and y into both equations. Take the point that you have, the point is an x value and y value. You're going to plug the x's and y's into both of the equations. If the equations are valid, is really the best way I can describe it, and the point is the solution. I'll explain what I mean by valid. So what I mean by valid is when you guys plug the x value and the y value in, if you evaluate all those numbers and whatever's on the left-hand side is the same as what's on the right-hand side, that's a valid equation. You would want to end up like 2 equaling 2, or 1 equaling 1, or 10 equaling 10. That's what you're after. If you get something like 2 equals 7, is that a valid equation? Then those x's and y's didn't work. Okay, so that's what we're after. And you guys have to check for both. If you plug it into one equation and it works, you have to also plug it into the second equation and make sure it works. Because it has to work for both equations to be a solution. So let's try this one. You don't have to rearrange anything. There's no rearranging involved. I'm going to plug 3 into the x's and 0 into the y's. So for this one, I would get 0. Here, I'll remember. So I get 0 plus 9. And then 12 minus 3. Yes. So you're showing me like what the numbers could be after you plug them in. So for the first equation, I would get 0 plus 9 equals 12 minus 3. Is that true? It is. Because 0 plus 9 is 9, 12 minus 3 is 9. That works for the first equation. Just because it works for the first one, does that mean that it's a solution? No, it has to work for both. So I'm going to do the same thing. I have 0 over here, and then I have 2 times 9 minus 36 plus 18. So I have 18 minus 36 plus 18. Is that going to be 0? Does that work out to be 0? Okay. So then it works for both equations, so would 3, 0 be a solution? That's the whole process that you guys are following. You don't actually have to solve the system to see if the solution you get ends up being 3, 0. You can check and see if a point is the solution by just plugging it in. Okay? Alright, same thing for this one. I plug in negative 1 for y, so I get negative 2. And I plug in 5 for x. 25 minus 30 is negative 5. Negative 5 minus 9 is negative 14.
No.
So would that work? If it doesn't work for the first equation, do I need to bother trying the second one? So if it works, or sorry, if it fails for at least one of them, it's automatically, nope, it didn't work. Because -2 equaling -4 makes no sense. Alright, last one. I have 15 for y, and then I have 1 for x. Or the first one, -8 plus 23, the same thing as 15. Pretty sure that's right. Let me try again with the bottom one. That's -8 plus 11 plus 12. That's okay, so that's still 15. So would 115 be a solution? That's just another learning target you guys need to be able to work through is given a solution or given a point, can you tell the solution? Alright. So as promised, alright, I'm going to go back to the very first slide. Remember, you guys are responsible for the paper or the homework assignment that I have on the blackboard. You guys can figure out your notebook or print it out and completing it. You guys also need to continue on with your slides project. You guys should have done problems 2, 3, and 4. That would have been your linear quadratic 1 solution, linear quadratic 2 solutions, and linear quadratic no solution that we set up last time. You guys are going to keep going. You're going to have problem 5. The question is answer key. That's going to be quadratic. So both of your equations have to be parabolas now. 1 solution, 2 solution, no solution for 5, 6, and 7. So you guys have 3 more pairs of slides to add on as you guys are working through your homework on this lesson. If you want to start fiddling with that right now, you guys still have about a little over 10 minutes if you want to start working on that. Otherwise, you guys are good to go. You can let me know if you have any questions about class that you can address now so you're not struggling at home. Otherwise, you can maybe work on spiral review, something for another class. Just try to stay productive.